You know, when you point to a laptop sitting on a desk, it's a very comforting boundary. The computer is inside that physical shell, and everything outside is just, not the computer.
Right. Yeah, we treat it like this discrete, self-contained box.
Exactly. But if you look at this new report from BEAI Research, the one called Everything's Computer,
Yeah.
it turns out that physical box is actually choking modern computing.
Yeah, totally. I mean, we have millions of edge sensors, massive cloud farms, global AI networks running constantly.
And trying to run all that through a traditional operating system kernel it's basically like forcing a massive 12-lane superhighway through a tiny single-lane toll booth.
It just doesn't work.
Right. So welcome to today's deep dive, where our mission is figuring out how to smash that toll booth.
Because to survive this inflection point, we have to fundamentally shift from a device-centric worldview to a network-centric one.
Okay, so the kernel, the core brain of your OS, it can't just be a static traffic cop for a single processor anymore.
Exactly. It has to evolve into a flexible, distributed platform.
So if the monolithic kernel is the bottleneck here, how do we actually fix it? Because reading through the BEAI sources, it seems like they realized you can either make the kernel infinitely smarter or just, completely lobotomize it.
Which is a pretty wild choice, right?
Yeah.
Let's look at the smarter route first.
Okay, let's unpack this. The neurosymbolic kernel. From what I read, it's basically an AI project manager for your hardware.
That's a great way to put it. It uses what are called loadable kernel modules.
And those are just chunks of code it can dynamically swap in and out, right? Like to adapt to live workloads without actually having to reboot the whole system.
Right, yeah. And as an AI project manager, it handles that dynamic shifting by using a probabilistic reasoning layer.
Wait, a probabilistic layer?
Yeah, it calculates uncertainty. It actually draws on this historical computer science concept called lottery scheduling.
Oh, right. I remember this part.
So imagine giving every process running on the computer a handful of literal lottery tickets. The scheduler randomly draws a ticket. This guarantees that every process, no matter how tiny, has a non-zero chance of running.
Oh, wow. Which completely prevents resource starvation.
Exactly.
So even if the AI is aggressively prioritizing a heavy video render, your background email sync still gets a winning ticket eventually. It doesn't just freeze up and crash.
Precisely. But then, the report pivots to the exact opposite extreme.
Right, the lobotomized version, the hypervisor-based kernel.
Yeah, instead of intelligent complexity, this architecture just strips almost everything away,
It pushes nearly all the operating system functions into virtual machines or VMs.
leaving only a bare-bones hardware abstraction layer to actually touch the physical chips.
But wait, I have to push back here. Doesn't routing absolutely everything through virtual machines cause, massive performance lag? I mean, you're essentially running a computer inside a computer.
You would think so, right?
Hmm.
But the data from the report counters that assumption entirely.
Really?
Yeah, the CPU overhead stays incredibly low. We're talking just 1 to 5%.
Wait, just 1 to 5%? How?
The secret is utilizing modern pair virtualization and zero-copy techniques.
Okay, zero copy, meaning instead of the system taking a piece of data, making a copy of it, and handing that copy over to the virtual machine.
The VM is just allowed to read the data directly from the hardware's memory.
Wow. So by eliminating that redundant copying step, you just completely bypass the traditional processing lag.
Exactly. And because the core is completely stripped of device drivers and networking stacks, it's essentially a separation kernel.
Oh, like the ones used in early IBM System 360 mainframes.
Spot on.
And they use those in safety-critical avionics too, right? You isolate everything, so if one VM, say your web browser, gets compromised by malware, the rest of the airplane, or in this case, the system, is perfectly contained.
Unassailable security through rigid minimalism. So we have dynamic probabilistic AI on one side.
And isolated, stripped-down security on the other. Wait. If the hypervisor strips everything down to purely secure isolation compartments, couldn't you just, I don't know, run that highly intelligent AI kernel inside one of those secure VMs?
And there is the ultimate aha moment of the report.
They combine them.
Yes. The hypervisor serves as an immutable, secure foundation, and then it hosts the neurosymbolic kernel on top of it as a highly privileged service VM.
So if this hypervisor and the AI are quietly managing resources across the globe, what does it actually feel like when you sit down at your desk to type?
Well, it creates what they call a logical workstation.
Okay, a logical workstation.
Right. You interact with it as if it's a single unified machine sitting right in front of you.
Yeah.
But under the hood, the AI is pulling processing power from cloud clusters.
Oh, and it's seamlessly connecting to what the report calls unikernels, right?
Exactly.
This tiny stripped-down apps running on-edge devices like a smart thermostat or a local router designed to do just one specific task instantly.
Yep. The underlying complexity is entirely invisible to you.
The report lays out a 4-phase roadmap to make this real, moving from prototype modules all the way to full edge-to-cloud benchmarking. It's a massive shift.
It fundamentally changes what it means to compute.
Which brings us back to that physical shell on your desk. If your computer is no longer a discrete box, but, a transient probabilistic web of shared global resources and single-purpose edge unikernels, where does your personal machine actually live? Something for you to chew on.